Hello, my name is Dustin Seetoo. I am the Director of Product Marketing here at Premio Inc. Our core capability for the last 35 years has all been on designing, manufacturing, industrial-grade computing machines. That is actually tied into a lot of this major trend that's moving into artificial intelligence and machine learning. A lot of this compute is what's driving the brains behind a lot of these new devices that are pinging data, smart, intelligent data. And at Premio, what I do specifically is working with all the technical teams and really bridging a story for our products. Lots of times when you think about a computer, there's not much going on, but there are a lot of key transformative technologies that are driving how the computer works. Everything from your high-performance compute, memory, storage, connectivity, right? Even the ruggedization of the product of the computer. There's so many technologies behind that really drive the performance for a lot of these major trends. And my goal as the product marketer is to bring color, bring light into these products, so then end users and potential clients can actually use these products to help solve a lot of their problems and their challenges in the world. We've been focused on in the last 35 years, and by the way, I kind of want to bring you on a little storytelling journey here. We just reached a major milestone of ours. We just reached our 35th anniversary. And within that 35th anniversary, there was a lot of key milestones in that. And how I want to kind of shape that story and really tell you that story is heavily built around computing architecture. So if you go back to when we were founded, 1989, what we did there was we really solidified in North America and Canada an OEM white box PC for a key market, and that was the education market, K through 12. And we were a top 3 leader in that business space. And we really were pushing volume of OEM white box. I don't know if you remember the PC days in the computer labs. I did that. I had to go learn how to use a computer, but everyone knows how to use a computer these days. But by then, as you know, the computing commodity turned into something that was more of an everyday tool, right? So how we actually became more resilient, more adaptable, and really built our infrastructure as Premio, I call it Premio 2.0. What we did there is we really emphasized our core capability in the system integration, manufacturing, reverse logistics, supply chain management. Here in this facility, 150,000 square feet, full automation lines. And what we really focused on at that time was working with major leader tier 1 EMS contract manufacturing. And in that contract manufacturing, we really honed our ability turnkey to really get any type of product from design, manufacturing, supply chain, reverse logistics support to full deployment. And where we are today since 2010, right, for the last 15 plus years, we've emphasized in our design, engineering, and manufacturing of our core key products that go into a lot of edge computing, machine learning, industrial touch displays, and high performance servers that are moving from the cloud all the way out to the edge. Yeah, so edge computing is extremely broad. And what we did in the last year, and I'm really proud of the Premio team and family, is we really positioned ourselves and we actually defined what edge computing means for Premio. Like I mentioned, for the last 35 years, we've been focused in computing. But more importantly is how you define the compute architecture where we are today and why it's beneficial for the market. So if you look at edge computing as a whole, very simply, right? The definition is moving a lot of this data processing, storage, high performance network all the way from the cloud out to the edge, right? And what that's doing is that it's actually providing the real-time processing that you need in order to interact where the data is being generated. If you were able to use the cloud, right, it would be actually, latency would be way too much, right? So by moving a lot of that processing power closer to these IoT sensors, you're actually able to deliver real-time performance, real-time business insights, and what that drives is productivity, autonomy, efficiency for key applications that tie into a lot of manufacturing, intelligent transportation, security and surveillance, right? These things are actually going to be moving into autonomy. And what Premio defined and what we positioned ourselves in a lot of this edge computing is what we defined in our ebook is rugged edge computing. And what does rugged edge computing mean is that we're taking a lot of this computing architecture and we're adding a layer of cherry on top with our key industrial core designs. Everything from our industrial heatsink chassis that's able to be resistant to shock and vibration, wide operating temperature, wide power input, all of this working with key technology vendors from memory, storage, CPU, we're able to push the product into mission critical, reliable environments for ultimate durability. Edge computers and rugged edge computing to Premio, right? We always think of it in somewhat of an uncontrolled environment. And that is the definition of a cloud, right? The cloud is controlled, it's resource intensive, there's redundancy built in place. But where a lot of our computers are actually being deployed, and a lot of them where they live, is I call it like the brethren of the IoT sensor, right? The IoT sensor is sitting something where it's remote. It could be mobile. So if you move that computing power closer to these IoT sensors, you're gonna be in environments that are often harsh, right? The temperature is not gonna be as stable. There could be kinetic movement in a lot of shock and vibration. The power might be unstable. So our main goal through a lot of our design, through our UL certification for safety, all that ties into the environment, right? And we, as Premio, have all the design equipment, environmental chambers to really push the product into these extremes with the key technologies, allowing the product to be strong and robust. Yeah, so great question. Where these IoT sensors live, right, and why it would need an edge computer really is this trend that we're starting to see. So a lot of the major market analysts, right, by 2025, you're gonna have 75 billion connected devices. Connected devices are anything from IoT sensors, right? It can be cameras, mostly are gonna be high definition cameras, but these are also sensors. And basically what these sensors are data points, right? And these sensors are aggregating data. But when you're aggregating data, right, it's just data. And when you had the big data boom, right, you were just collecting data. But in order to actually process that data, you need some type of device. And that is where the computer comes in. And what we have done in our core capability is designing an extremely ruggedized computer with the transformative technologies from CPU, processor, memory, storage, I/O connectivity, and wireless connectivity, right? And that sits as close to the IoT sensor. So in that edge continuum, the data from the IoT sensor can ping machine to machine in a low latency environment, millisecond-wise, and make decisions very quickly. And that is what's driving these key trends in the major market, which is edge AI, artificial intelligence, and machine learning, and it all built around computing. The goal is autonomy, right? So within the ecosystem, everyone's working together for that major goal. And that major goal, what I've defined and what I've learned in the industry is called the closed loop of autonomy. And why you have a closed loop of autonomy is because once you're able to build that autonomy of data path, right? Data moving to IoT or IoT sensor, moving to edge compute, funneling data that's most critical into the cloud, back and forth, you're creating an autonomous loop. And when you have autonomy, right? And that not only is just to remove the human element of that, you have real-time decision making, you can actually achieve better business insights and have ultimate productivity in a lot of these new major markets like smart manufacturing, security and surveillance. So if you look at all the technology behind computers in general, or the difference between a desktop computer and a ruggedized computer, pretty much the same. But the applications are different, and that's why it's so important. So if you look at a regular computer, I would say the biggest trend that everyone probably knows about is gaming, right? Gaming PCs have all the red RGB lights, flashy, cool, bells and whistles. But if you break down the technology, what does it include? You have a motherboard, you have a CPU, you have memory, you have storage, you have I/O, you have connectivity enclosed in a chassis with active cooling, right? All those technologies are using the latest transformative technologies from all the key silicon. It can be for processor, memory, storage, and you're achieving the most performance that you can get out of that, right? Carbon copy that and put that into an industrial application that is looking for the same type of performance, needs the reliability in volatile memory, You need redundancy and storage. You need to have the I/O connectivity. But the key there is these computers are pushed into environments where it's unstable. And the challenge that we're constantly dealing with and why our customers come to Premio is we're able to deliver an extremely ruggedized computer with the high performance key technologies, right? But most importantly, help them achieve a faster time to market with an off-the-shelf product, right? With our certified products, computing products. Yeah, so I would say the biggest industry where you're seeing the most growth of industrial computing or ruggedized computing would be industrial smart manufacturing. And that ties into the ability of using a lot of autonomy, but autonomy goes into a lot of robotics. So if you think of what robotics are, right, without any of the computing, without any of the software algorithms to drive the intelligence of it, it's just bare metal, right? It's just a metal that can't do anything. But the beauty of why computing is so explosive and why we're moving into this new level of edge AI is this robotic arm now is being trained with data, now being trained with machine learning algorithms based on what compute is, right? And it's using hardware acceleration to eliminate a lot of the labor intensive work that humans used to have to do, right? And in a lot of these smart manufacturing applications, you're gonna have robotic arms, autonomous guided vehicles or robotics moving throughout logistics facilities to help manage a lot of this autonomous efficient tasks that no longer need to be done by humans. Another major market I would like to kind of emphasize is intelligent transportation. So intelligent transportation can tie into a major different things. I think the one major market everyone really understands is autonomous vehicles. But autonomy in terms of vehicles from a commercial side is one thing, but if you break that down into businesses, there's a lot of intelligent transportation that's built into municipality. So that can be through buses, railways, intelligent trucking, right? All of this is being built upon sensory data that's being funneled into edge compute running real-time decision making for that type of application. How edge compute ties into something like that, I would actually dive into more of a smart city. So what smart cities are essentially are a bunch of different data at different intersections that communicate with machines, right? So with that data point of 75 billion connected devices, a lot of these devices are going to be deployed in a smart city that has the connectivity pinging into the computer, right? When you have, most importantly, utilizing, for example, a major trend of 5G connectivity, right? Specifically on sub-6 millimeter, you can actually do very low latency, right? Enhanced mobile bandwidth and do machine-to-machine communication. And you don't even need to use the cloud. And when you have that smart city, for example, before you even get to a traffic light, right? They already can kind of manage the direction on traffic. Another key example, another case study of ours is intelligent transportation and tolling, right? So they've eliminated the human element of it and actually made it more autonomy. Everything from the payment system, everything from a license plate reader, everything from human recognition, right? All that going in and out of the tolling has all been autonomy. And what is working behind the scenes, right, as a technology vendor in computing are these key transformative technologies that are making it happen. Ruggedized computer, extremely high performance processing, volatile memory, storage, and wireless connectivity. So some of the major customers that come to Premio for our industrial grade edge computers range from OEM system builders, system integrators, and most importantly, some of these end users. Right, we as Premio for the last 35 years sit farther down the supply chain, and our core capability is to design, manufacture, and globally deploy industrial grade computing for these clients and customers who potentially are not just focused on building a computer, but they realize that in order to drive their success, right, and their actual application into market, the brains behind a lot of it is a computer. And what we do very quickly and what we do best is we help them reduce that time to market. right? When you reduce that time to market with a trusted, reliable partner that has the technology backbone built in place with an industrial grade computer, they can actually move their product or their solution into their customers and solve their problems extremely fast. And that's why we live and breathe by a certain motto here at Premio, where for our clients, it's your success is our commitment.